Today we have very interesting topic, that is why do generators use KVA instead of the kWA. Generators are rated in the kVA, that is the kilovolt ampere, instead of the uh, kilowatt, because kVA measures apparent power, which accounts for both real power, that is the kilowatt, and the reactive power kVAR. So there are some reasons behind this. First one, power factor consideration. First one is the power factor considerations. The real power, that is the unit of the real power is the kilowatt. This is the actual power that performs the work in the system. Next one, we have the reactive power, that is the kVAR. This is the power that oscillates between the source and the load, necessary for maintaining the magnetic and electrical fields in the inductive and capacitive loads. Next one, we have the apparent power. The unit of the apparent power is the kVA. This is the vector sum of the real power and the reactive power and represents the total power generated must be and must supply. The relationship between the these types of the power is given by the equation, that is the kVA is equal to kW divided by the power factor. Since the power factor can vary with the different loads and conditions, the generators must be rated to supply the total apparent power kVA regardless of the power factor. The second reason is the load variability. Loads can be resistive, inductive, or capacitive, affecting the power factor. A generator must handle the varying the power factors because the total apparent power kVA determines the generator's capacity to supply the power under the different load condition. Rating generators in the kVA ensures they are sufficiently robust to handle the total current demand, including the both real and the reactive components. The third reason, we have the standardization and the versatility. Ratings in the kVA provides a standardization measure that applies to the various applications without specifying the load type. This makes it easier to compare the generators and understand their capacities across the different usage. By using the kVA, manufacturers can design generators and meet a broad range of needs, ensuring they are not limited by the specific types of the loads they might encounter. Electrical system design, fourth region. Electrical components like the transformers, conductors, and generators are typically rated in the kVA because they are designed to handle total apparent power, which affects their thermal limits and the voltage regulation capabilities. Using kVA accounts for the fact that both real and reactive contribute to the total current that components must handle, ensuring the system reliability and the efficiency. Next, the region is the generator's efficiency and the performance. Efficiency and the performance of the generators are influenced by both real and the reactive power. By rating the generators in kVA, it ensures that their design considers all aspects of the power delivery, enhancing their ability to operate efficiently under various conditions. So, in summary, we can say that generators are rated in the kVA to encompass the total apparent power they must deliver, considering both real and reactive power, and to ensure compatibility with the varying power factor of the different loads. This approach provides a more comprehensive and standardized measure of a generator's capacity and performance.